Curious why the sky is blue, or maybe why Mercury looks so different from Earth? Welcome to A Space Story, where we explore the details of our solar system. In this video, we're going to share some basic facts that everybody should know and discover what makes each planet unique. Check the description for references. Thanks for watching and enjoy. Mercury, the closest planet to the Sun, orbits at a distance of about 1/3 that of Earth. It's the smallest planet in our solar system, with a diameter of 3,032 miles, just larger than Earth's moon. Interestingly, Mercury is slowly shrinking. Over billions of years, its diameter has reduced by approximately 9 miles as its iron core cools and strengthens, causing the planet to reduce in size. Mercury's surface, without an atmosphere, is covered with many craters, like the Moon. Meteor impacts have left marks on it, with the Caloris Basin being the biggest at 963 miles wide. It formed 3.8 billion years ago from an impact by a 62-mile object, which is about the size of a large part of Western Europe. Mercury orbits around the Sun in only 88 Earth days, making it the fastest orbit of any planet in our solar system. Its name comes from the Roman god Mercury, who was the god of merchants and thieves and tricksters. In Roman stories, Mercury wore winged sandals and a helmet, showing his quick nature. Despite its small size, Mercury faces drastic temperature changes because it lacks an atmosphere. Daytime temperatures can reach up to 800 degrees Fahrenheit, while nighttime temperatures drop to a freezing -269 degrees Fahrenheit. These extreme changes happens because Mercury's thin atmosphere can't hold on to heat, letting temperatures vary greatly between day and night. Mercury rotates exceptionally slowly on its axis, requiring nearly 59 Earth days to complete just one full rotation. This elongated day on Mercury equals almost 2 months on Earth, exposing its surface to extended periods of extreme heat and cold. In 2012, a green meteorite found in Morocco showed similarities in composition to data from NASA's Messenger probe, which studied Mercury from 2004 to 2015. Scientists believe these meteorites may have originated from Mercury, possibly ejected during impacts and later arriving on Earth. Mercury shows phases like the Moon from Earth due to its proximity to the Sun and orbital position relative to us. Unlike Earth's moon, Mercury has no moons of its own due to its small size, weak gravity, and proximity to the Sun, making it difficult to capture and keep a moon in orbit. Exploring Mercury is tough because it's so close to the Sun, which makes it hard for spacecraft to navigate. Only 2 missions have successfully studied Mercury up close: Mariner 10 in 1973 and Messenger in 2004. Mariner 10 took the first close-up pictures of Mercury, but only flew by the planet. Messenger orbited Mercury for 4 years, studying its surface, composition, and magnetic field before crashing into the planet's surface in 2015. Venus, often called Earth's twin because of its similar size and structure, is the second planet from the Sun, positioned about 67 million miles away. Despite its peaceful name, Venus is far from peaceful. It's so hot on Venus that it could easily melt lead, turning it into a liquid in seconds. Imagine the kind of heat that could burn down a house in an instant. Venus has a diameter of around 7,521 miles, making it slightly smaller than Earth. However, its thick atmosphere, mainly carbon dioxide with clouds of sulfuric acid, creates a powerful greenhouse effect that traps the heat. This results in an average surface temperature of about 867 degrees Fahrenheit, making Venus the hottest planet in our solar system, even hotter than Mercury despite its greater distance from the Sun. Venus has an extremely high atmospheric pressure, about 92 times greater than Earth's. This pressure is similar to what you would experience deep under Earth's oceans, due to the heavy weight of Venus's thick atmosphere. Venus rotates in the opposite direction from most planets in our solar system, a phenomenon known as retrograde rotation. If you were on Venus's surface, you'd witness the sun rising in the west and setting in the east. The planet has large volcanic plains, impact craters, and tall mountains, but lacks the tectonic activity seen on Earth. Its volcanoes, such as Mons, reach heights of up to 5 miles, making them some of the largest in our solar system. Despite its proximity and numerous space missions, Venus remains largely mysterious. Its dense atmosphere blocks visible light, making direct surface observations difficult. However, radar imaging from spacecraft like NASA's Magellan has provided detailed maps of Venus's surface, revealing its volcanic terrain and geological past. Venus's runaway greenhouse effect provides valuable insights into Earth's climate and the potential impacts of unchecked greenhouse gas emissions. By studying Venus, scientists gain an understanding of how planets evolve differently based on their atmospheres and distances from their host stars. Venus has no moons and has been visited by only a few spacecraft. NASA's Mariner 2 in 1962 was the first successful flyby mission to another planet. More recently, the European Space Agency's Venus Express orbited Venus from 2006 to 2014, studying its atmosphere and surface in depth. Exploring and studying Venus continues to reveal the extremes of planetary environments, offering valuable lessons about both the history and future of our planet Earth. Earth, the third planet from the Sun, is our home and the only known planet that supports life. It orbits the Sun at an average distance of about 93 million miles, within a zone where conditions are just right for liquid water, a crucial ingredient for life as we know it. Have you ever wondered why the sky appears blue? It's due to a phenomenon called Rayleigh scattering. When sunlight enters Earth's atmosphere, it encounters molecules and small particles. The shorter blue wavelengths of light are scattered more than the longer red wavelengths by the gases and particles in the atmosphere. This scattering causes the blue light to be more visible to our eyes, giving the sky its blue colour. With a diameter of approximately 7,918 miles, Earth is the largest of the terrestrial planets, which include Mercury, Venus, Earth, and Mars. It ranks as the 5th largest planet overall in our solar system. Earth's size enables it to maintain a diverse and dynamic environment, featuring oceans, continents, and an atmosphere that sustains a rich variety of life forms. Earth's atmosphere is mainly composed of nitrogen, about 78%, and oxygen, about 21%, with small amounts of other gases such as carbon dioxide, argon, and water vapor. This mix of gases acts as a shield, trapping heat and regulating temperature, creating a stable climate that supports life. The Earth's surface is divided into several rigid tectonic plates that float on the semi-fluid mantle beneath. These plates are constantly moving, shifting at a rate of a few centimeters per year. This movement leads to earthquakes, volcanic eruptions, and the formation of mountains over long periods. Earth's rotation on its axis creates day and night cycles, completing one full rotation approximately every 23 hours, and 56-minute a period we call a day. This rotation influences weather patterns, ocean currents, and Earth's climate by distributing heat globally. Earth's magnetic field, created by swirling molten iron and nickel in its outer core, forms a protective shield against dangerous solar and cosmic radiation. This shield safeguards Earth's atmosphere from being eroded by the solar wind, essential for sustaining life on our planet. Water covers about 71% of Earth's surface, filling oceans, seas, rivers, and lakes. Driven by the sun's energy, the water cycle circulates water between the atmosphere, land, and oceans through evaporation, condensation, precipitation, and runoff. This cycle sustains ecosystems and supplies vital resources for human civilization. Earth is home to a wide variety of life, ranging from tiny bacteria to large trees and complex animals. This diversity flourishes in Earth's different climates, habitats, and ecosystems, each uniquely suited to its environment. Mars, known as the Red Planet, orbits the Sun as the fourth planet. Positioned between Earth and Jupiter, its reddish appearance stems from iron oxide, known as rust, which covers much of its surface. With a diameter of roughly 4,212 miles, Mars is about half the size of Earth. Its atmosphere, mainly carbon dioxide 95% with traces of nitrogen, argon, oxygen, and water vapor, is significantly thinner than Earth's, creating a significantly different environment. The Martian surface features expansive plains, towering volcanoes like Olympus Mons, the solar system's tallest at approximately 13.6 miles, and Valles Marineris, a vast canyon system stretching over 2,500 miles long and depths of up to 4.3 miles. Due to its thin atmosphere, Mars undergoes extreme temperature swings. Daytime temperatures near the equator can reach about 68 Fahrenheit, while winter night temperatures at the poles drop to about -243 Fahrenheit. The average temperature on Mars is around -81 Fahrenheit. Mars has two small moons, Phobos and Deimos, both asymmetrically shaped and likely captured asteroids from the nearby asteroid belt. Phobos orbits very close to Mars, completing a revolution in less than 8 hours, while Deimos orbits farther out, taking about 30 hours for one orbit. The planet's polar ice caps consist mainly of water ice and dry iced carbon dioxide ice. These caps expand and contract with Martian seasons, akin to Earth's polar ice caps, but on a larger scale. The presence of water ice hints at the potential for liquid water beneath Mars' surface, both in the past and possibly today. Various space agencies, including NASA and ESA, have targeted Mars for exploration. Landers and rovers such as Viking, Spirit, Opportunity, Curiosity, and Perseverance have provided crucial insights into its surface, geology, climate, and potential for ancient habitability. Mars remains a focal point for ongoing research and future exploration efforts, with plans to send humans on missions in the coming decades. Understanding Mars' history and geology helps scientists unravel the mysteries of planetary formation, solar system evolution, and the search for extraterrestrial life. With its unique features, challenging environment, and potential as a destination for human exploration, Mars continues to captivate scientists and space explorers alike. Advancements in technology continually enhance our knowledge of Mars, paving the way for future missions and groundbreaking discoveries. Jupiter, the largest planet in our solar system, is a gas giant positioned fifth from the Sun, nestled between Mars and Saturn. Its colossal size earned it the name of the Roman King of Gods, reflecting its gravitational dominance over other planets. With a diameter of about 88,846 miles, Jupiter is over 11 times wider than Earth. Despite its immense size, Jupiter spins rapidly, completing one rotation in approximately 9.9 hours, which shapes its recognizable cloud bands and storms. Jupiter's atmosphere is mainly hydrogen, about 75%, and helium, about 24%, resembling the Sun's composition. It also contains traces of methane, ammonia, water vapor, and other gases that contribute to its vibrant bands and swirling storms. Among its features, Jupiter boasts the Great Red Spot, a colossal storm larger than Earth that has been observed for over 3 centuries. This anticyclonic storm reaches wind speeds of about 270 miles per hour and spans a diameter 3 times that of Earth, adding to Jupiter's distinctive appearance with its multitude of storms and bands. Jupiter boasts a robust magnetic field that is 14 times stronger than Earth's, extending its magnetosphere millions of miles into space. This field traps charged particles, forming intense radiation belts that present challenges to spacecraft and exploration missions. Although fainter than Saturn's, Jupiter also possesses a ring system composed of dust particles and material ejected from its moons due to impacts and radiation. These rings add to the planet's cosmic allure, Jupiter hosts at least 79 moons, including Ganymede, the largest in the solar system. Other notable moons like Callisto, Io, and Europa exhibit diverse features such as volcanic activity, subsurface oceans, and icy surfaces. Jupiter's immense size and gravitational pull profoundly influence the solar system, shaping the orbits of nearby planets and asteroids. Its gravitational force has played a pivotal role in shielding Earth from potential asteroid impacts by redirecting or capturing many incoming objects. Spacecraft like Voyager, Galileo, and Juno have extensively studied Jupiter, unraveling its atmosphere, magnetosphere, moons, and internal structure. These missions continuously enhance our understanding of Jupiter's intricate and dynamic environment. Saturn, the sixth planet from the Sun and the second largest in our solar system, is renowned for its spectacular rings, which are its most distinctive feature visible from Earth. Named after the Roman god of agriculture and wealth, Saturn's rings consist of icy particles ranging from tiny grains to several meters in size, encircling the planet in distinct bands. Saturn has a diameter of about 72,366 miles, slightly smaller than Jupiter, but still more than 9 times wider than Earth. Despite its size, Saturn's average density is less than water, suggesting it could float in an enormous bathtub if one were large enough. The planet's atmosphere is mainly composed of hydrogen, about 96%, and helium, about 3%, with traces of methane, ammonia, and water vapor. Its visible cloud bands, like those on Jupiter, are caused by winds blowing at speeds up to 1,100 miles per hour. Saturn's rings consist of billions of icy particles, ranging from micrometers to several meters across. These particles are believed to be remnants of comets, asteroids, or moons that shattered due to impacts or were torn apart by Saturn's tidal forces. Saturn hosts at least 82 moons, with Titan being the largest, even larger than the planet Mercury. Titan stands out among Saturn's moons due to its thick atmosphere, predominantly made of nitrogen, akin to Earth's, and surface lakes of liquid methane and ethane. Saturn's interior likely includes a rocky core enveloped by layers of metallic hydrogen and liquid hydrogen, although the precise structure remains a subject of ongoing study among planetary scientists. While Saturn's magnetic field is weaker than Jupiter's, it still generates a magnetosphere that extends beyond its rings. This protective shield interacts with the solar wind, shielding Saturn and its moons from harmful radiation. Spacecraft like Voyager 1 and 2, Cassini-Huygens, and the Hubble Space Telescope have provided extensive data and images of Saturn's rings, moons, atmosphere, and magnetic field. These missions have significantly enhanced our understanding of this gas giant. Saturn's exploration continues to intrigue scientists, who are eager to uncover more about its rings, moons, and distinctive atmosphere. Upcoming missions, including NASA's Dragonfly mission to Titan, hold promise for further discoveries. Saturn's mesmerizing rings, renowned for their intricate patterns and stunning beauty, remain a captivating subject of study, offering insights into the dynamic processes shaping planets and moons across our solar system and beyond. Uranus, the seventh planet from the Sun and the third largest in our solar system, is an icy giant known for its unusual rotation and tilted axis. Discovered by William Herschel in 1781, Uranus is named after the Greek god of the sky. Uranus is about 14 times more massive than Earth and has a diameter of approximately 31,518 miles. Its atmosphere is mostly hydrogen and helium, with a hint of methane that gives it a distinctive bluish-green color. One of Uranus's most notable traits is its extreme tilt. Unlike other planets, Uranus rotates on its side, with its axis nearly parallel to its orbit. This unique orientation leads to dramatic seasonal changes, with each pole experiencing 42 years of continuous sunlight, followed by 42 years of darkness. Uranus possesses a system of faint rings composed of dark particles and dust, akin to those found around Jupiter, Saturn, and Neptune. These rings were first detected during a stellar occultation in 1977 and further explored by Voyager 2 during its 1986 flyby. Uranus has 27 known moons, with Miranda, Ariel, Umbriel, Titania, and Oberon being the largest. These moons vary widely in size and composition, displaying distinct surface features such as cliffs, canyons, and icy plains. The interior of Uranus is believed to consist of a rocky core surrounded by layers of icy and liquid materials, including a mantle of water, ammonia, and methane ice. However, the exact composition and structure of Uranus's interior remain uncertain due to its distance from Earth and limited exploration. Uranus possesses a faint and variable magnetic field that is tilted relative to its rotation axis. This magnetic field interacts with charged particles, producing auroras similar to Earth's northern and southern lights, but much fainter. Exploration of Uranus has been minimal, with Voyager 2's flyby in 1986 providing valuable data on its atmosphere, rings, and moons. Future missions like NASA's proposed Uranus Orbiter and Probe missions aim to delve deeper into this distant ice giant, uncovering more about its unique characteristics and evolution. Uranus's peculiar features, from its extreme axial tilt to its icy composition and enigmatic magnetic field, make it a compelling focus for astronomers and planetary scientists seeking to understand its place in the universe and its role in shaping planetary systems. Neptune, the eighth planet from the Sun, is a gas giant known for its deep blue colour and active atmosphere. Discovered in 1846 and named after the Roman god of the sea, Neptune's hue resembles the ocean due to methane in its atmosphere absorbing red light. Neptune is massive, about 17 times Earth's mass, with a diameter of around 30,598 miles. Its composition includes hydrogen, helium, and traces of methane, giving it its distinctive blue appearance. One of Neptune's notable features was the Great Dark Spot, a massive storm similar to Jupiter's Great Red Spot, observed by Voyager 2 in 1989. Though the Great Dark Spot has since faded, other storms and atmospheric phenomena continue to be studied on Earth. Neptune has faint rings and at least 14 known moons. Triton, its largest moon, orbits in a retrograde direction, opposite Neptune's rotation. Triton's icy surface is covered in nitrogen frost, likely originating from the Kuiper Belt before being captured by Neptune's gravity. Neptune's atmosphere is turbulent, with winds reaching speeds of up to 1,300 miles per hour. This creates extreme weather, including large storms and dark vortices that appear and disappear over time. Inside Neptune, there's a rocky core surrounded by layers of icy and liquid materials, possibly including water, ammonia, and methane ice. The exact makeup of Neptune's interior remains uncertain, but its dense atmosphere indicates a significant presence of volatile gases. Neptune boasts a faint yet potent magnetic field tilted relative to its axis. This field interacts with charged particles, generating powerful auroras akin to Earth's northern and southern lights, but on a grander scale. Our exploration of Neptune has been limited to Voyager 2's 1989 flyby, which provided invaluable insights into its atmosphere, rings, moons, and magnetic environment. Future missions, like proposed ice giant explorers, aim to delve deeper into Neptune's complex system and unravel its origins and development. Neptune's lively atmosphere, dynamic weather, and intriguing moons make it an engaging focus for scientists and astronomers. A continued study promises to reveal more about its place in the solar system and how it compares to other gas giants like Jupiter and Saturn.